Okay, Assalamualaikum warahmatullahi wabarakatuh. We are from K4. So we are producing nanocellulose from anti-fruit bunch. So I am Ishani Limited Momrizan and my teammate is Su Yin, Fatina Nur Ain and also Gagan Tiran. Our supervisor is Prof. Madia, Dr. Norina Anwar and also Dr. Faragami. So for introduction, nanocrystalline cellulose can be used as antiviral and antibacterial for alcohol-free sanitizer gel. Nanocellulose sourced from biomass, which is empty fruit bunch, and its use would generate a great environmental advantage compared with other non-bio-based material. So nanocellulose can be used in pharmaceutical, food, and also medical industry. For CAGR, the research showed that the global demand for nanocellulose market stood at 13,000 tonnes in 2015, and the global market for nanocellulose from 2016 to 2021 is expected to grow at CAGR 30%, and from 2020 to 2037, nanocellulose market is expected to grow at 20.4% during the forecast period. So our plan decided to contribute 3% from the demand in 2025, which is 6,500 tonnes per year or 773.8 kilogram per hour.
So the industrial location is an important thing to determine patterns of manufacturing because it can affect the efficiency and profitability of production. Here are some suggestions to do the plant location, mainly Kantan Industrial Park Perak, Kapar Industrial Park Kapar Selangor, and also Jalan Bandar Kembangan, Kampung Pulau Manis, Pahang. So we done the weightage analysis. Based on the weightage evaluation, Kapar Industrial Park Kapar Klang Selangor has been chosen as the plant location. For the economic analysis, we found out that the minimum acceptable rate of return is 0.25. The net return is 4.77 million. The net present value is 64.27 million. And also the net discounted rate of return, DCFRR, is 0.79, which is lesser than 0.25, which is our minimum acceptable rate of return. So our plan is financially feasible. For the safety and hazard identification, we referred a few acts and regulations, namely Environment Quality Act 1974, Act 127, Occupational Safety and Health Act 1994, and also Factory and Machinery Act 1967. Based on these acts, we analyzed the chemical hazard, biological hazard, mechanical hazard, health, electrical and electromagnetic hazard found in our plant to perform the hierarchy of the plant.
Next will be the list of the improvement of our project. First, we have updated the process flow diagram of the wastewater treatment plant in which the chlorination tank is removed from the PFD. We have included the reference in the section 5.1.2 and the set point value in charter process control. We also include the steam and cooling water for heater and cooler in both PFD and PNID diagram. We have included the information on the minimum price of our main product in the charter economy analysis. Next is the process flow diagram after heat integration. This is our piping and instrumentation diagram after HAZOP, in which we have include the controller and alarm.
Next, for main reactor design, for this reactor, which is they have acid hydrolysis process where water, cellulose, and also hydrochloric acid will enter the reactor, which take place at 110 degrees Celsius and 7 bar, and it will form nanocellulose and also glucose. And this is design calculation for the main reactor. The operating temperature of a reactor is 121 degrees Celsius and the operating pressure 111.7 psi, and the working volume is 73 meter cube, and the material used is stainless steel 316, and also the vessel height is 6.3 meter. And the vessel inside diameter is 1.5 meter. Type of vessel support is skirt, and the type of flange joint is welding neck. This is the mechanical design for the main reactor.
Next is the detailed design of the distillation column D102. So for this distillation column, due to the difference in the boiling point, hydrochloric acid will be vaporized as the top product and recycled back to the main reactor R101. The efficiency of 58.50%. Actual number of stages is 15 stages and the height is 10.0 10.637 meter and the inner diameter is 1.395 meter. Next is the mechanical design calculation for this column. Stainless steel type 316L is chosen as the construction material due to the corrosivity of the hydrochloric acid. Elixir 2:1 head is chosen for the design with 0.349 meter and the shear height of 9.940 meter is calculated. Type of the vessel support used is a thread skirt and the type of the furniture used is the class 150 wedding net. This is the mechanical drawing of the distillation column D102.
So for the detailed design of reboiler L101, a kettle reboiler is used to heat up the distillate from distillation column D101, which consists of xylose, dissolved lignin, acetone and sodium hydroxide. The distillate will be heated up until 200 degrees Celsius, which vaporizes all the components in distillate completely through this stream into the distillation column 101. For the mechanical design of the reboiler, the corrosion allowance would be 0.02 meter, and also the type of vessel support would be the saddle support, and the type of flange would be 200 PS 1560 carbon steel. Apparently, this is the mechanical drawing of the reboiler L101.
Next is mixing tank M101, which is acetone and water will mix at the operating temperature 28 degrees Celsius and pressure 5 bar. The shell of the mixing tank is cylindrical. The top and head, the bottom head is spherical, and the material of the mixing tank is the stainless steel type of 0304L. The vessel height is 2,400 millimeters. The shell height is 5,596 millimeters, and the head height is 402 millimeters. The thickness of the mixing tank is 6 millimeters. The corrosion thickness is 2 millimeters. Next is the mechanical drawing of the mixing tank. Next is plant layout. The economical construction and efficient operation of the process depends on how well the plant and equipment specified on the process flow sheet is laid out. Site layout is the effective arrangement for the industrial facilities, building equipment in the plant. In our plant also, we made sure we had this element, which namely as assembly area, administration office, car park, canteen, clinic, control room, final product storage, parking area, and then power supply, QA and R&D lab, wastewater treatment plant, warehouse. And then we also consider the wind direction when making this plant layout. Next is waste management. Before we calculate the COD, BOD and SS, first we assume that the density of water is 937.5 kg per meter cube, and then the BOD value is 0.3 COD. The concentration of xylose we get 1088 11.2 mg per liter. COD concentration is 34789 mg per liter, and the suspended solid is 27239 mg per liter. And then the PFD of the wastewater treatment.
So for the conclusion, our process is produce nanocellulose where the empty fruit bunch as our material. EFB will undergo two processes such as pre-treatment process and also acid hydrolysis process. Our site located will be at Kappa Industrial Park, Kelang Selangor. The plant capacity for our nanocellulose is 6,500 tonnes per year or 773.8 kg per hour. The waste management in our plant is wastewater treatment only. Several legal requirement act that related in our production are EQA 1974, OSHA 1994 and also FMA 1967. Thank you.